everyone, today we're going to talk about section 11-4, volume of spheres. So you'll notice we have this sphere drawn here, and the volume formula that we have is that the volume is equal to 4/3 pi r cubed. Okay, so I'll show you guys how to type everything into the calculator because we will be using that. R is of course the radius. When we're talking about a three-dimensional sphere, it's kind of like a ball, a perfect circle in 3 dimensions. So we're gonna do a couple of warm-up pieces, and we're actually gonna make a comparison between our values that we found. So starting with this hemisphere is what we call this. Okay, so that's half of a sphere. So I would just use half of the formula. So I've got 1/2. Now my formula says we're gonna do 4/3 pi r, so my radius is 10, and then cubed, okay? So typing this into my calculator, I'm gonna ignore the pi for a minute, and let's just do the numeric portion of this. So I'm gonna multiply these fractions and also the 10 cubed. So I'm gonna put this 1/2 in parentheses. Okay, maybe it might be helpful to put parentheses here. Another parentheses with 4/3 in it. So 4 divided by 3. And then we've got 10 to the 3rd power. Okay, so you're gonna wanna use this caret button right over here. Okay, so that will raise you into an exponent. Okay, so I'm gonna hit enter, and you'll notice we have a decimal, but essentially this is 666.6 repeating, or we could write that as 2/3. Now I still have a pi in there. Okay, so for our purposes right now, I'll just leave this alone. Maybe we'll come back to it, but for now we'll just leave that alone. Okay, so our next figure is a cylinder. We saw this previously. So our formula is area of the base, so we're gonna have pi r squared times the height. Okay, so if I were to, again, ignore the pi for a minute. So we've got 10 squared times another 10. We have 1,000. So I've got 1,000 pi. Okay, and then finally we have our cone. So the cone formula is 1/3 area of the base, so that's pi r squared, times the height. Okay, so ignoring pi for a moment, we've got 1/3 times 10 squared times another 10. And that gives me 333 1/3. Okay, pi, and what are our units here? So we've got meters cubed for all of these, okay? Now, the reason why I wanted to show you guys this problem, it's kind of a discovery problem. Notice that this is a hemisphere, right? So that's half of a sphere. If I were to double this, okay? So doubling would give me 666 2/3. Let's actually go back up to that. Okay, let's double that. And we get 1333 1/3. Okay, so we'll say the full circle, or full sphere, would be 2 times the hemisphere, which is 1333 1/3 pi. So if we're making some observations, that full sphere is the same as if I were to add these two together, okay? So you'll notice that if everything else in the equation stays the same, notice my height was 10, my height was 10. The radius was 10, the radius was 10. Basically, I'm just adding the coefficients in the front. Well, if I add 1 plus 1/3, okay, getting common denominators here, we have 4/3. Okay, and you'll notice if you look back at our original formula, it was 4/3 pi, notice that's in both of our equations, r cubed, because there are 3 radii being multiplied. Notice I've got 10 squared, but then another 10. So we just discovered where that formula came from. Okay, now I'm not going to ask you guys to recreate the formula. As long as you have it, you can use it. Okay, but this was an interesting one where I felt that, you know, showing you guys why it came from this where this fraction actually came from was actually useful. Okay, so let's do some practice problems. So the drama club makes a big ball from foam to hang above the stage for a play. They plan to cover the surface of the ball with a metallic fabric. What is the minimum number of square meters of fabric that the club needs? Now, there's something else that we're using in this section, and it's another formula. This time, it's our surface area formula. Okay, so surface area is, let's say we have this ball. The surface area is the total area that you can touch. So the entire surface of that figure. And it does go in 3 dimensions because you're going all the way around the ball. So if I know that the surface area is what I'm looking for, I definitely need to know that radius, okay? Now we know that the volume of the sphere, this was given to us, is 1.8 meters cubed. Now, using my formula for the volume of a sphere, I can substitute what I know. Now in this case, I know the volume. I can substitute 1.8 on that left-hand side. So at this point, it's just about solving for the radius. So I'm going to show you guys a couple tricks as to how to do this. So first of all, to get rid of 4/3, we're going to multiply by the reciprocal. Notice I flipped the fraction, and I have to do it to both sides. Multiplying by 3/4 ends up canceling out this fraction. So I'm going to go in my calculator and do parentheses 3/4 times 1.8. So I have 1.35 is equal to pi r cubed. Okay. Now I still need to get rid of some stuff because I'm trying to get r by itself. So let's divide by pi to get rid of that value. So I'm just going to hit divided by pi, and I get 0.4297. I'm just going to keep a bunch of decimals for now, and that's my radius. Oh, sorry, that's my radius cubed. In order to find the radius, I now need to take a cube root. So the cube root of the previous answer, or you can type in 0.4297, gives me 0.6555. Again, I like to keep a lot of decimal places until I'm finished with the problem, because I'm actually not done with the problem at this point. We were asked to find the surface area of this figure. So the surface area is found by using our new formula. We've got 4 pi, I know the radius, 4 pi r squared. Okay, now I can type this into the calculator. Sorry about that, video got cut off. Okay, so we have our surface area. When we plug this all into the calculator, we have 5.399. I'm just gonna round to the nearest tenth, 5.4. Okay, now when you're talking about surface area, it's kind of like taking the area of a sheet of paper, okay? So the units are going to be meters squared. They're square units. We're not talking about volume here. It's not the depth or the amount of space that this takes up, but rather just how much actual surface is around the outside, okay? All right, so let's take a look at our next one. What is the largest volume a sphere can have if it's covered by 6 meters squared of fabric? So you'll notice again, this is referring to surface area. Okay, so if we know that the surface area is 6 meters squared, I'm going to use the surface area formula so that we can figure out the radius. Okay, now I need to get the radius by itself, so I need to divide by 4 pi. Okay, now when you type this into your calculator, you have to be careful. You need to put parentheses around the stuff that you're dividing by. Otherwise, it's going to give you the wrong answer. So I have 6 divided by, parentheses, 4 pi. That way you're dividing by this whole quantity. So I have 0.477. So now I'm going to take the square root of that to get r by itself, and I'm just going to hit the square root button and the previous answer, ANS, and we end up with a radius of 0.69. Now, if the radius of the sphere is 0.69, now we can jump to our volume formula, which I'll just rewrite over here. So I know the radius, I just need to plug that in. And now we can type it into our calculator. So in parentheses, always put this 4/3 in parentheses. Pi, the radius, cubed. Okay, again, to raise it to a power, we're using this button right here and then typing the number 3. So we end up with a volume of 1.376. So that's 1.4, what's our unit? Meters cubed. Okay. I didn't mention the rounding stuff in the directions here. On the homework, you guys can just round to the nearest tenth at the very end of the problem. If you want to keep more decimal places in between, that's better. Don't round in the middle of a problem. Wait until the very end and then round that to the nearest tenth. Okay? All right, so jumping to the next page. So we've got this little section talking about the volume of a hemisphere, and hemisphere is just half of a sphere. We already talked about that a bit. So that means instead of it being 4/3, so the volume of a sphere is 4/3 pi r cubed. Volume of a hemisphere is half of that, which is 2/3 pi r cubed. And I'll include the surface area formula here as well, just in case we need to use it. Okay? Now, I'm going to pause the video here. You guys can give the next couple problems a try. Go ahead and try examples 4 and 5. We'll come back and talk about the last two. All right, go ahead and check your solutions using our hemisphere formula. All right, finally, we're moving down to example number 6. A solid is composed of a right cylinder and a hemisphere. If the density of the solid is 100 kilograms per meter cubed, what is the mass of the solid? I'm going to ignore the second part of this question, and first we're going to focus on the figure itself. How do we find the volume here? So the volume is composed of two parts. We've got the volume of the cylinder plus the volume of the hemisphere. Now I can find the total volume because all of our values are given. You'll notice that the radius is just 1 because it's half of this diameter. So I'm going to find the volume of the cylinder. It's the area of the base, pi r squared, times the height of the cylinder. Now the volume of the hemisphere is 2/3 pi r cubed. So if we find the total volume, we can just type this all into our calculator and add it up. So we've got, pause that for a sec, there we go. Pi, 1 squared is just 1, so I'm just going to multiply that by 3, plus 2/3 pi. I know that 1 times itself 3 times is 1, but if you want to type it in, you can. Okay, and we get a total volume of 11.5. So that is our, let's see, we've got meters cubed. Okay, now the density of the solid is 100 kilograms per meter cubed. Okay, so if we think about this in terms of units, we have 11.5 meters cubed. And we know that for each, anytime you see this unit, kilograms per meters cubed, means for each meters cubed, actually it's 100, for each meter cubed, each 1 meter cubed, there are 100 kilograms. That's what a unit means, okay? So we have 11.5. So what we need to do here is multiply by 100, okay? And what ends up happening is you've got meters cubed on top, meters cubed on bottom, and that leaves us with our unit. Those of you guys who are taking chemistry, this is called unit analysis. You don't really have to worry too much about that in this class. I'll give you definitely much more straightforward problems. Okay, so I just multiplied by 100 and I got a final answer of 1150 kilograms. Okay, most likely I would just have you find the volume. Okay. All right, this last problem says if the height of the cylinder is equal to the diameter of the sphere, so the diameter is going to be twice this, so that's 24. What is the volume of the space between the sphere and the cylinder? So I'm not going to include the actual sphere. I want the space around it. So what we need to find is the volume of the cylinder and subtract the volume of the sphere. Okay, so I'm going to have you guys try this one. This is the last problem in the notes, and you guys can check the solutions when you're finished. Homework is posted, and it's going to be due Thursday night by midnight. All right, guys, have a great day.